Okay, so now let's do an example that requires us to use a class B address space. So we have three subnets divisions that need support for 200, 400, and 700 hosts. Okay, so let's try to find out the number of bits needed for each subnet for the host part. With 200 hosts, we need 8 bits for the host part because 2 to the 8 minus 2 is 254 and 2 to the 7 minus 2 is 126. So we have to go for 8 bits for the subnet A to support 200 hosts. For subnet B to support 400 hosts, we need 9 bits because 2 to the 9 minus 2 is 510 and 2 to the 8 minus 2 is 254. So we need 9 bits. And then to support 600 hosts, we need 10 bits because 2 to the 9 minus 2 is only 510 and we need at least 600 hosts, right? So we need to go for 10 bits. So we'll take the maximum of these three, which is 10. So we'll need 10 bits for the host part. Now we need three subnets, so we need 2 bits for each subnet, which is 0, 0, 0, 1, and 1, 0. So we need at least 2 bits for subnet and 10 bits for the host part, so we need at least 12 bits. With the class C address space, we can play with only the 8 bits of the host part. Remember, in subnetting, we can play only with the host part of a class-based address space. So the class C address space, we can use only 8 bits for the host part. So we need to use a class B address space where we have 16 bits in the host part, so we need only 12 bits. So what we are going to do is we'll use the last 10 bits. Remember, we need 10 bits for the host part here. So we'll use the last 8 bits as well as the last 2 bits of the third byte in the class B address space. So by the way, I'll use this class B address space. So it's up to you to pick any class B address space. In this example, I pick 170.40. Okay. Dot zero dot zero, that's a class B address space. You can pick 143.132 if you want to work with, or any valid class B address space. Of course, pick a public class B address space. Okay, so I pick here 170.40.0.0, that's a class B address space. So I'll use the last 10 bits of this for my first part, and then the immediate next to the one preceding these 2 bits for the subnet part, the 2 bits. So remember, you have 10 bits here and 2 bits here, so 12 bits. So we have 16 bits for the first part. So the first 4 bits are not going to be used. So I leave it as 0. Okay. So we have these 2 bits used for subnet, and then there's 10 bits for the first part. So 12 bits together. Okay. So now, what about the subnet mask? The subnet mask is nothing but a sequence of ones followed by a sequence of zeros. So the number of zeros indicate the number of bits for the host part. We have 10 bits for the host part here, right? So the number of zeros will be 10. So the preceding ones will have 32 minus 10, which is 22 ones. Okay, so that will correspond to these 8 ones for this byte, and then another 8 ones for this, then 4 ones for this, and another 2 ones for this. Okay, so you have 16 plus 6, which is 22 ones, followed by 10 zeros. So that will be something like this. This will be 8 ones, another 8 ones, and then you have 6 ones followed by 2 zeros. So 22 ones followed by 10 zeros. So these 2 zeros get here, and then you have 8 more zeros here. So we have here 255 for this, then 255 for this, and then this is 252, and then a 0. So now for subnet A, we have 0, 0 forming the 2 bits for subnet part. Remember, the first 4 bits here are to be zeros, right? And then you have these 2 bits as zeros for subnet part. For subnet address, all the bits in the host part are also zeros. So these 10 bits are also zeros for us. So that corresponds to 170.40. This is a 0, and then this is a 0. So 170.40.0.0/22, indicating 22 bits for the network plus subnet. Now the broadcast IP address, we have all the bits in the host part. These bits should be ones here, right? So these are all ones, and then you have still this 2 bits for subnet part 0, 0. So it's 170 dot. So this is a 3.255. So again /22. So now everything in between, so 170.40.0.1, something like this, okay, all the way, then 10 and so on, all the way to 9 ones followed by a 0, that is for the valid range of IP addresses. So 170.40.0.1, 170.40.0.2, all the way to 170.40.3.254 is the range of valid IP addresses. So how many IP addresses we have? So here you can go from 0.1 to 0.255. Remember, that's not a broadcast address because we're using 22 bits for network plus subnet and 10 bits for the host part. Then 1.0 to 1.255 is 256 addresses. Then 2.0 to 2.255 is again 256. And then a 3.0 to 3.254, which is 255 addresses. So add up all of them, you get 1022 addresses. Okay? So that's for subnet A. For now subnet B, you have 0, 1 for the 2 bits for subnet. The remaining is the same kind of approach. So you have 10 bits for the host part. So the subnet address is going to be 170.40.4, because if you look at these 8 bits together, that is a 4.0/22. And then you have 10 ones here for the host part, so it is 170 dot. Now if you look at this is going to be 7, 40.7.255. So everything between 4.1 to 7.254 is a valid range of IP addresses. So again, you have 1022 valid IP addresses. Now for subnet C, you have 10 for the subnet and this 10 bits for the host part are 0. So this together. If you look at this way, this is 8.0, that's 22.2. If you look at this is going to be 11.255. So 8.1 to 11.254 is a valid range of IP addresses. So each subnet will have 1022 IP addresses. So the efficiency of assignment is 200 for subnet A, 400 for subnet B, and 700 for subnet C. And you can support 1022 IP addresses for each of them. So the efficiency is sum of all these 200 plus 400 plus 700 divided by 1022 added 3 times, that is 42.4%. Okay. Now let's continue. So let's do CIDR now. So what's the difference between actually subnetting and CIDR? Subnetting, you will be given like we had here different divisions where you want to support certain number of hosts in each division. So we'll take one address space like a class B or class C address space and divide that into multiple subnets. Okay. Whereas with CIDR, we want to support only one network, like a network with 700 hosts, but we cannot do that with, say, one single class C address space. So we'll try to use multiple class C address spaces, okay, and kind of aggregate them into one single network address. So for this purpose, we cannot use any randomly chosen class C address spaces. We have to use class C address spaces that are contiguous to each other, so that we can capture the common bits in the network part and then kind of summarize all these three or how many number of class C address spaces we use as one single class, one single network address. Okay, so that's why we need to choose contiguous address spaces. Okay, so let's do this example where we have to support 700 hosts. So we are given with these three class C address spaces: 212, 45, 16.0, 17.0, 18.0. So the first step is to write them in binary. So this is 212.45.16.0 and this is 212.45.17.0, 212.45.18.0. So I open up the 16, this is 17, and then this is 18. So if you find the common bits, 212 is common, 45 is common, like in these 6 bits are common. Okay? So the difference starts from this bit, right? So I'm going to call these 8, 8, and then these 6 bits to represent my network part, and then the remaining these 2 bits and these 8 bits represent my host part. So this 2 bits plus 8 bits is 10 bits for the host part, and 32 minus 10, 22 bits for my network part. So I'm going to call my network part to be something like this. The network address is this, the common bits, 2, 12, 45, and the 6 common bits. And then you have the host part, these 10 bits are all zeros. So it's 212.45. If you look at just these 6 bits, it's going to be 16.0 slash 22 to indicate the subnet mask. Okay? Basically, that indicates number of bits for the network part here. Okay? And then for the broadcast address, this is our network part, right? So the host part is basically this. So all these 2 plus 8, 10 bits have to be ones. That's what we have here. So 11.255, right? Sorry, not 11, 11.255, but you now put these 8 bits together. This is these 2 bits, last 2 bits for the host part along with this, right? 10 ones. So now if you put these 8 bits together, that's going to be, this is 16 plus 2 plus 1, 19.255. So now you see, even though you purchased only 3 class C address spaces, 16.0, 17.0, 18.0, because of this, you see, you need to also purchase a 19.0 address space. Okay, so that's your broadcast IP address. So you'll go for a 16.0, 17.0, 18.0, and a 19.0 address space. Okay. So again, the subnet mask is based on the number of bits for the host part. We have 10 bits for the host part, so we have 10 zeros preceded by 22 ones. So that is 255.255.252.0. So that's our subnet mask. So now the valid range of IP addresses starts from here, 16.1 to 19.254. So the number of such IP addresses is again 255 in the 16.0 space, and then 256 in 17.0 to 17.255, and then 18.0 to 18.255, and then 19.0 to 19.254, that is 255 addresses. So put together is 1022. We want to support 700 unique IP addresses. So the efficiency of assignment is 700 over 1022, which is 68.5%. Okay. So that is with CIDR. And so let's do this example where you want to identify the type of IP addresses based on classless addresses here. So 212.40.90.63/26. So the 26 indicates the subnet network plus subnet part. So we have 32 minus 26, 6 bits for the host part. So I write this thing in binary. So this is 90 dot, this is 63. So 63, we have 6 bits in the host part, right? So these are the 6 bits for the host part. The last 6 bits, they are all ones. So you can directly say it is a broadcast IP address. Okay. Now this is 80.0/20. So 20 means 12 bits, 30 minus 20, 12 bits are used for the host part. So this is going to be my 80, okay, and this is going to be my 0. So these are the 12 bits for the host part, 8 plus 4. So these 12 bits are all zeros, so we can say this is subnet address. Now 32 minus 20 is not 5 bits for the host part, so these are the last 5 bits, right? And this is our 32 here, right? So the last 5 bits which are representing the host part are all zeros, so that is again a subnet address. Now 28, so 32 minus 28, 4 bits are used for the host part. Now this is 12. So the last 4 bits represent the host part, so they are all non-zeros and not all ones. So that's a simple unicast IP address. Then you have 755.21, 32 minus 21, 11 bits for the host part. Okay, so this is your 7, and this is your 255. So the last 11 bits on these, they're all ones, so that indicates a broadcast IP address. Okay, so let's stop this with this.